Question number 1. A discrete random variable x has a probability distribution xi with values -2, -1, 0, 1, 2 and corresponding probabilities k, 2k, 2k, k and 2k. To estimate the value of k is a question. Now you can see that x is a discrete random variable because it has taken discrete values and these are the assigned probabilities. We know that if x is a valid random variable, the sum of the probability should be equal to 1. I is equal to 1 to 5 because there are 1, 2, 3, 4, 5 values. That means k plus 2k plus 2k plus k plus 2k is equal to 1. So this becomes 8k is equal to 1, k is equal to 1 by 8, which is equal to 0.125. So you can see that option C is correct. So this is hardly anything, but I think it's a good startup for students who are learning probability for the first time. Sum of the probability should always be equal to 1. So this is based on that. So once you know the value of k, you can put it back into the distribution and do many calculations. For example, you can find the mean, variance, you can find moments and so many other things. So let's go to the next example. Question number 2. What is the variance of the random variable x that has a distribution with xi -1, 0, 1, 2, 3 and corresponding probabilities 0.3, 0.1, 0.1, 0.3 and 0.2. So we want variance. So you can write variance of x like this. We have a definition, expectation of x minus mean whole squared. So this is first required. So we'll first compute the mean. How do you calculate the mean? It is expectation. And how do you calculate expectation? Summation xi into pi, where I takes values 1, 2, 3, 4, 5. I is equal to 1 to 5. So sum of the products of these two. So minus 1 into 0.3 is minus 0.3 plus 0 plus 0.1 plus 0.6 plus another 0.6. So 0.6 plus 0.6, 1.2, 1.3 minus 0.3, which is equal to 1. So this is the mean of the distribution and that is required here. So how do you compute this? Summation x minus 1 whole squared into pi. I is equal to 1 to 5. X values are these values. So how do you calculate this? From each x value subtract 1 square and then multiply with the corresponding probabilities. For example, I'll show you. This will be -1 whole squared into 0.3 plus 0 -1 whole squared into 0.1 plus 1 -1 whole squared into 0.1 plus 2 -1 whole squared into 0.3 plus 3 -1 whole squared into 0.2. So if you calculate, this will be 4 into 0.3 plus 1 into 0.1, next is a 0 plus 1 into 0.3 is 0.3, then 4 into 0.2. So this will be 1.2 plus 0.1 plus 0.3 plus 0.8. So 1.2 plus 0.8 is 2. So we'll get some 2.4 as the variance. So it's a very simple calculation if it's a discrete probability distribution. Okay, or just remember your formulas. Without the mean, you cannot calculate the variance. That's the basic thing that you must remember. Of course, you can also calculate by other formulas, but nothing wrong in adopting this formula. You can see the correct option for this problem is found in C. Question number 3. What is the mathematical expectation of a random variable x that denotes the number appearing when a fair die is tossed? So the experiment here is a fair die is being tossed. So when a fair die is being tossed, the sample space will consist of these 6 outcomes. Each will have a probability 1 by 6 because it's a fair die. All of them have equal probabilities. So what is the distribution? X is equal to xi pi. 1, 2, 3, 4, 5, 6, with all of them getting equal probabilities. What we want is expectation of x. We know this stands for the mean. So this is summation xi pi, I is equal to 1 to 6. So it is 1 into 1 by 6 plus 2 into 1 by 6 and so on, 6 into 1 by 6. So it is 1 by 6 into 1 plus 2 plus 3 plus 4 plus 5 plus 6. So this is 1 by 6 into 6 into 7 divided by 2 using the n into n plus 1 by 2 rule. So 7 by 2 is the mean or the expectation. So the correct option is A. So many times distributions are not given, but you will have to build your own table, probability distribution, and then estimate the required statistic. Question number 4. What is the variance of the random variable that denotes the number of heads when a pair of coins is tossed? Now, when a pair of coins is tossed, we have already seen the sample space consists of 4 outcomes. So the probability distribution is already known to us. 0 heads, 1 head, 2 heads with probabilities 1 by 4, 2 by 4, 1 by 4. What we want is a variance of x. So variance of x is nothing but expectation of x minus mean whole squared. But first we must calculate the mean. So what we do is, we'll calculate the mean, which is expectation of x, as summation xi pi. So 0 into 1 by 4, 1 into 2 by 4, plus 2 into 1 by 4. So this is 2 by 4 plus 2 by 4, which is equal to 1. So in the variance, we will have x minus 1 whole squared. So this is nothing but summation xi minus 1 whole squared into pi. These are the xi values. So 0 minus 1 whole square is 1 into 1 by 4 plus 1 minus 1 is 0 plus 2 minus 1 is 1 into 1 by 4. So 1 by 4 plus 1 by 4 is half. So this is the variance of x. Option A is the correct option. In fact, with some experience, you will be able to predict what the mean is, because you can see this distribution is already symmetric in terms of probabilities. Therefore, it was expected that the mean would be 1, that's the center. But guessing the variance is not such an easy thing. Question number 5. What is the value of k such that f of x is equal to k into 1 minus x squared for 0 less than x less than 1 and 0 otherwise is a valid density? So let's go back to our basic concepts. F of x is a valid density if the integral of f of x dx from minus infinity to plus infinity is equal to 1. This is the definition. In this problem, the integration takes place over 0 to 1 because that is where we have non-zero density, and in other ranges we don't have to integrate. So you set integral 0 to 1 f of x dx is equal to 1. Replace f of x with this function. So k times integral 0 to 1 minus x square dx is equal to 1. So k times x minus x cube by 3 from 0 to 1 is equal to 1. So k times 1 minus 1 by 3 is equal to 1. K into 2 by 3 is equal to 1. So k is equal to 3 by 2. So for this value of k, we can call this as a density. Once you use this value of k here, you can estimate any probability, of course within this range only. Okay, the correct option for this problem is B. Question number 6. Determine the mean of the random variable that has a density f of x is equal to k times e power minus x by a, where x is greater than 0 and a greater than 0. The moment we know that this is a density, the calculations are based on integration. So observe that a is some constant which is already given, but k has to be found. Unless k is found, you cannot calculate the mean. So there are two steps. Step number 1, determine k. How do you do that? You integrate the density function. Observe this carefully. You have to integrate from 0 to infinity. So this is nothing but integral 0 to infinity k e power minus x by a dx is equal to 1. So k times e power minus x by a by minus 1 by a from 0 to infinity is equal to 1. That means minus ak times e power minus infinity is 0 minus e power 0 is 1. So ak is equal to 1. So k is equal to 1 by a. So unless this is found, you cannot go to the main issue of finding out the mean. So let's go to the second part. Mean of x is equal to expectation of x, which is integral x into the density function from infinity. So 0 to infinity x into the function is this function. So that is k times e power minus x by a dx. But k is already 1 by a. So we can keep 1 by a outside and integrate x e power minus x by a by parts. So we can integrate by parts. X here 1 e power minus x by a by minus 1 by a e power minus x by a by 1 by a squared. So we have integrated by parts. So you can see that this is a negative term, this is also a negative term. So therefore I can take a negative sign outside. So minus 1 by a into e power minus x by a is a common factor into ax plus a squared 0 to infinity. So when you apply the upper limit, you will get a 0 minus 1 into a squared. You will get a square by a, which is equal to a. So this is the mean. So determining the value of k is first important, then apply the expectation rule to find out the mean. And integration, of course, requires the basic things like integration by parts, sometimes substitution, but here it was straightforward. Correct option for this problem is A. Question number 7. A continuous random variable has a density f of x is equal to k in the range a less than x less than b and 0 otherwise. Find the variance of the distribution. Now, even though this is a very simple example, why we chose to do this problem is in engineering normally we study a distribution called the uniform distribution. The uniform distribution is one of the simplest of the distributions whose mean variance are all well known. So we will derive this and remember them as a standard result. Okay, as usual, first we'll find out the value of k. Step number 1, integrate from a to b f of x dx equated to 1 because it's a density. So a to b k dx is equal to 1. So k into x from a to b is equal to 1. So k into b minus a is equal to 1. So k is equal to 1 by b minus a. So if you actually look at the graph of this distribution, in the interval a to b, the density is k. K is a constant, and that constant happens to be 1 by b minus a. So this height is 1 by b minus a. So this is the total density. It is also called a rectangular distribution because the shape of this distribution is rectangular. Right. We need variance, but before that, let us not forget we must calculate the mean. Mean is expectation of x, which is nothing but integral from a to b x into the density. So what do you get? The density is k, where k is 1 by b minus a. So take 1 by b minus a outside, integrate x, you will get x square by 2 from a to b. So you will get b square minus a square by 2 times b minus a, and you can easily see this is b plus a by 2. That was expected because the mean for this nice distribution is the midpoint of this interval, which is a plus b by 2. That was expected. So if you know the graph of the density, many times you can guess the results. Now we come to the main calculation. Variance of x is equal to expectation of x minus mean whole squared. Equivalently, this is nothing but expectation of x squared minus the square of the mean. You can use any of these two formulas. Suppose we do this one, it is a to b x square f of x dx minus the mean square. F of x is again 1 by b minus a, so you take it out and integrate, you will get 1 by b minus a integral a to b x square dx minus the square of the mean. Integration is very easy, but a little bit of algebraic simplification will be required. So you will have 1 by b minus a x cube by 3 a to b minus square of the mean. So what do you get? You will get b cube minus a cube by 3 times b minus a minus b plus a by 2 whole squared. So how can we simplify? Factorize this, and 1 b minus a will get cancelled, and you can take the LCM of 3 and 4 as 12, so 1 by 12, and what do you get? B square plus ba plus a square times 4 times this minus 3 times b plus a whole squared. So let's work out. 4b square minus 3b square is b squared. 4ab minus 6ab is minus 2ab plus a square by 12. So this is nothing but b minus a whole square divided by 12. It's a very well known result in the uniform distribution and very simple algebraic manipulation. I don't expect students to get stuck in algebraic manipulations at this level. So b minus a whole square by 12 is the variance. The correct option for this problem is C. Question number 8. What is the variance of the random variable x whose density function f of x is equal to 1 by b into e power minus x by b, where x is greater than 0 and the parameter b is greater than 0. Again, this was selected not because of any great difficulty, but this is a well-known distribution in communication engineering and otherwise in other areas also. This is called the exponential distribution. Now, everything is clear. We can directly get into the calculations. In fact, you don't have to verify that this is a density. It has been declared to be a density. So first we'll calculate the mean. Without the mean, there is no variance. So this expectation of x, which is integral 0 to infinity, that is because x is greater than 0, x times the density. So let's integrate this. Integrate by parts. So we'll have all the routine operations. So b square by b will be b. So this is the mean. Now comes the required calculation to find out the variance. So variance of x is equal to expectation of x squared minus the square of the mean. So integral 0 to infinity x square into density minus square of the mean. Density is here, of which 1 by b can be taken out. X squared e power minus x by b dx minus square of the mean. Integration by parts, slightly long calculation. X squared 2x 2 e power minus x by b by minus 1 by b e power minus x by b by 1 by b squared e power minus x by b by minus 1 by b cube. Integration part is over and all of them inside are negative. So we'll take out the minus sign outside. We'll take e power minus x by b common in all the terms. So we'll have bx squared plus 2b square x plus 2b cube minus square of the mean. Calculations become very simple now because of the upper limit. E power minus infinity becomes 0 minus 1 into, only this will survive, 2b cube minus square of the mean. So 2b cube by b is 2b square minus mean is already b. So square of the mean will be b squared. So 2b square minus b square is b squared and the correct option is C. Now what is important about this problem is, I'll put it as a summary. Mean is b, variance is b squared, so its square root, that is the standard deviation, is also b. So this is one of the rare distributions where the mean and the standard deviation are the same. If you go back and look into distribution theory, you will find that this is one of the rarest distribution having mean and standard deviation equal. There is one more distribution called the Poisson distribution in which the mean and variance are equal. We'll come to that issue in the next lecture.